Hello everyone and welcome to Code Confidence. Today we are looking at a problem called Top K Frequent Words from LeetCode, problem number 692. Let's read the problem statement first. Given an array of string words and an integer k, we need to return the most frequent strings, the k most frequent strings. Okay, so our input becomes an array of words and an integer k. We are expected to return the answer sorted by the frequency. So it is possible that there can be words in the array which have the same frequency. In that case, we have to break the tie by lexicographical order. What is the lexicographical order? Lexicographical order means alphabetic order, the way they appear in the dictionary. Alright, so let's look at the constraints first before moving on. We have an array of words which can contain a minimum of one word, so it's not going to be empty, and a maximum of 500 words, so it can be large. The length of each word can be either 1 character or 10 characters. The words themselves are small in length. Words I consists of lowercase English letters, so we don't need to worry about capitalization or any other kind of special characters. And then finally, k is in the range 1 to the number of unique words in the array. In the worst case, there can be n unique words in the array, where n is the length of the array. So k will range from 1 to n in that case. Alright, so let's discuss some example cases first and then we will solve the problem. Whenever you see a phrase like top k in any problem, that problem is usually solvable by using sorting or using special data structures like a heap. We will try to see if we can solve this question using a heap. Okay. In our case, we are given a list of words which can range from 1 to 500. So in the simplest case, I can take words array to be consisting of a single word. Let's call this word I. Okay. And then we have k, which is an integer that can range between 1 and the number of unique words in the array. For our case, let's take k to be 1. So we need to return the top 1 most frequent words in this array. So we can see that the answer will be I, because there is only one word in this array. What if we had two words? Like if I have an array which has I and U in it, and let's say that the value of k is 1. So we want the most frequent word in this array. You can see that I appears 1 times and U also appears 1 time. What will be my answer? The problem says that whenever there is a tie, you need to follow the lexicographical order. In the lexicographical order, I comes first before U, and so our solution will be I. Suppose we have 3 words. I appears 2 times and A appears once. And let's say the value of k is again 1. In that case, our answer is again I. But this time it's because the number of times that I appears is 2, which is larger than the number of times that A appears, which is 1. So what we need is a way to store the frequency of each word, and we can do that using a data structure like a HashMap, which is perfect for cases like this, to store how many times something is appearing in a sequence. So we can do this using a HashMap, And then based on that frequency, we need to find out the top keywords, for which we can use a heap. So by combining the hash map with a heap, we can arrive at a solution to this problem. Let's go ahead and code this. Alright, so let's start writing the code for this problem. We discussed that we need to store the frequency of these words. For that, we can use a hash map, and in Python, we can create that like this. So we can write word frequency is equal to an empty dictionary. Then we can say for word in words, we can write word frequency of the word is equal to word frequency dot get word comma 0 plus 1. What this line of code is doing is, if this word is already present in the word frequency dictionary, then get the value of that word from here and then add 1 to it, because we have seen it again. And if it is not present, then this will return 0, which indicates that this word is not present and we are seeing it for the first time, and then we add 1 to it. Okay, so now we have our word frequency. We now need to create a heap where we can store these words. So for Python, I can do that by importing a heap queue module. From there, I can utilize the features of the heap class that Python offers. Now this import function, notice that I am writing it inside this function top k frequent. You can also write the import statement at the top of the program like this. Both ways are acceptable. Let's just write it here. Okay, so we imported the heap queue module. Now I need to create a heap. By default, Python gives us the min heap implementation, but we need to store these numbers in decreasing order of frequency. So we need a max heap. So how do we do that? We can do that by taking the negative value of the frequency of each word. Alright, so we can write this now as for word comma count in word frequency dot items. So I am taking each of the item and its frequency. And now what we can do here, heap queue dot heap push heap. So we are adding to the heap using this heap push method, which comes from the heap queue module. So heap, what are we adding? We are adding a tuple which contains the negative of the count and the word itself. The way this works is the heap queue module takes this part and uses it to sort first, and if that doesn't work out, like when the counts of the two items are same, in that case it takes the word value in the lexicographic order. We are using a negative value here for the decreasing order of the counts. Alright, so we have added all the items to the heap. Now we can take our result array, and since it's a max heap, the topmost item is the one with the maximum frequency. So what we can say is for I in range k, we are going to pop out one item from the heap and add it to our result. We can say count comma word. Why count comma word? Because we have added the tuple in this fashion is equal to the heap queue dot heap pop and from the heap. Now notice that we had added the negative value of the count here. So this count value is going to contain the negative of the frequency of the word. But this is irrelevant for us now because we are only going to be concerned with the word value. So we take out the word from this and then result dot append word. So we are only taking out k items from this result. And now we can just return the result. Alright, so that is our code. Let's try to run and see if it works. Our test cases are passing. Let's submit this. And we get an accepted solution. Even though the performance is not that great, but it's accepted. Alright. Now let's talk about the time complexity of this solution. So as you can see, we are taking a loop here and we are storing every word in a hash map. So this runs for the length of the words, and if the length of the words array is n, then this part is order of n. Okay. Then we import the heap queue module, and then we have another loop here where we are running the loop through the word frequency.items array. If all of the words are unique in the array, then in the worst case, this will also be equal to n. So this loop will run n times. Within the loop, we are doing heap push, which is log of n. So this part has a time complexity of O(n) log n. The upper loop had O(n) and here we have O(n) log n. And then finally we are compiling our result by running another loop. And this loop is running k times. And we are popping in this loop also. So this is k log k. So as k is upper bounded by n, so the overall time complexity of our solution is O of n log n. And we used a max heap to solve this question. Then let's talk about the space complexity. We are using a word frequency dictionary that will store all the words. It is possible that all the words are unique and their frequency is 1. In that case, the length of this word frequency will become order of n. And therefore our space complexity is also order of n. Okay, so that is our solution to this problem. There is an interesting follow-up part in this question which says, can you solve this question in O(n) extra space, which we are already doing it using our frequency, but what they want is the time complexity to be O(n) log k. Right now, our time complexity is O(n) log n. Alright, so how do we improve our solution from O(n) log n to O(n) log k? Why is it the solution O(n) log n? Because we are saving every item in our heap. If somehow we keep the size of our heap less than or equal to k, then our work is done. So if we can say something like, if length of heap is greater than k, then you remove the item from the heap. So we can say heap queue dot heap pop heap, so that the length of the heap is always less than or equal to k. But if we use this, then the item that gets popped from the heap will be the item with the maximum value of count, because we are using a max heap. So directly this code is not applicable. In order to keep the heap at maximum length of k, we need to use a min heap now. We can do that by removing this minus sign from here, and then our heap becomes a min heap. But then we again have a problem, which is now the heap will contain the least frequent items in the array. How do we solve that issue? So this cannot directly be done by using a simple tuple. The tuple compares based on these two values, which is count and word. Now count is supposed to go in decreasing order, whereas word is lexicographic or in the alphabetical order. So we need a custom comparator function with which we can compare each word with the other words in the heap. That is why we define a new class that you see in all the solutions out there. Inside the class, we will define our comparator function. So we will say class word, and then we will give it an init function which will take a word value and a count value, and then initialize this word as the given word value and the count value. Now, inside this, we will define our comparator, which is _LT, which is for less than. This function needs to be named LT. It's a default name that Python gives us for any class that can have a comparison operator. So LT, we will give it other word value. Now here we will say if the count of our word is not equal to the count of the other word, in that case we will return whichever count is smaller. So self.count is less than other.count. Otherwise, when their count values are equal, in that case we will return whether our word is lexicographically smaller or larger than the other word. But since we are going to keep the smaller word in our heap, we will return it in the opposite manner. Now since we are using return statements, so this else is not required. I can write it simply as this. Okay, now we have our word class defined. So let's go ahead and use it. We can replace this count word tuple here by our word class. So I can say heap, then we add a word that is formed by our word and its count. So word comma count. These word objects can easily be compared to each other using the less than method of the word class. Alright, so we added all these words into the heap, and whenever the length of the heap becomes greater than k, then we pop this item from the heap. So when now we do the pop, it will remove the smallest item from the heap because this is now a min heap. Alright, now we need to modify our code in this part because we have a word now. So we will say that when you pop the item, take the word value as the item that was popped dot word, because we only need the word part of this word object. Alright, and then we append that to our result. Now this result array is formed by popping items from the min heap. Therefore, we need to reverse this result to get our solution. Okay, now if I run this, we have an accepted, and the time complexity for this will change now because our heap is never going to exceed the size k. So the time complexity for this will become O n log k. Okay, let's submit our solution and see if it works. It's an accepted solution, and that's how with using a min heap we can solve this question. Alright, so that's it for this video. We will meet again in another one. See you there.